All right, welcome to our last section on polynomials. Polynomials, and this is actually the last section on last section of 5.5, polynomials applications to geometry. So let's see what we can apply to geometry here. So if we've got, we'll go all the way back to the beginning. This is 5.5, addition and subtraction of polynomials, and let's apply some of the stuff that we've learned. Some of the stuff that we learned to polynomials. Remember, if we're adding polynomials, a plus b, well, then we just add like terms. We just add all the x's and all the y's and all the xy's together. Like terms mean that you've got terms. Remember, terms are separated by addition. Like terms are terms that have exactly the same variables to exactly the same exponents. All right, so that's addition. Subtraction was something like this, and we got to kind of pay attention a little bit to subtraction, I guess, because subtraction is something that's a little bit more different. A little bit more different. If we've got a minus b, that's the same thing as a plus the negative b. And that positive b polynomial becomes negative, or becomes negative by changing the sign or changing the changing each individual component or term in that polynomial to its opposite. So a minus b is the same thing as a plus the opposite of b, where the b, all the terms in b change to the opposite, and then they can be added to a. All right, so with that in mind, let's take a look. Hopefully this will work for us. Let's change to blue. All right, it does. All right. Let's take a look at this example. If the perimeter of a triangle in the figure can be represented by the polynomial 2x squared plus 5x plus 6, that's our perimeter. Find a polynomial that represents the length of the missing side. So let's just start out by saying this is side A, this is side B, and we're looking for side C, let's say. All right, so if we start out with the polynomial, or the equation that the perimeter is equal to A plus B plus C, we're going to solve for C because we don't know what C is. So we're going to leave C over here. We're going to move A and B to the other side by subtracting A from this side, subtracting A from that side. We get P, perimeter, minus side A equals, these guys cancel out. We've got B plus C. And we're going to do the same thing with B because we're going to solve for C. Eventually we're going to have C over here by itself and P and A and B over here. We got to subtract b over there. We got to subtract b over there because we got to treat the twins, the kids, equal at Christmas time, right? This would be p minus a minus b equals c because these guys cancel out. All right, so there's our c side is equal to the perimeter minus a minus b. All right, so let's take that and say here's what we're going to start with. My perimeter minus side A minus side B is equal to side C. So let's write that again. P minus, hang on a second. P minus A. Let's see if that works. All right, P minus A minus B equals C. And that's eventually what we're going to look for. We're going to look for the missing side, C. All right, so now we're just going to fill in some numbers here, or some variables, or some polynomials here. The perimeter here is given up here, so we're just going to fill that in as 2x squared plus 5x plus 6, and that's our perimeter. Minus side A, well, side A is right here, 2x minus 3. And we have to put that in parentheses because we're subtracting all of A, and all of A is that. So there's our A polynomial. We're subtracting A right there. We're going to do the same thing for B. We're going to subtract everything that's in B. Everything's in B is right there. X squared plus 1. And that will be equal to C. And that'll be what we're looking for. All right, so now we've got something like A minus B equals A plus the opposite of B. But we've got some polynomial here minus another polynomial. Oh, and we're doing the same thing for minus another polynomial. So when we subtract a polynomial, we're adding the opposite. So we're going to start off with writing our A polynomial, our first polynomial, as no changes to it. And then when we subtract, remember the other analogy I used was, instead of subtracting a polynomial is the same thing as adding the opposites. The other analogy I used was this is a mean guy, he changes to a happy guy when everything in here changes to the opposite. So negative becomes positive if 2x becomes negative 2x and minus 3 becomes plus 3. Same thing holds true over here. When we subtract b, we're adding the opposite of b. Adding the opposite of b means changing every sign in here to everything else, to the opposite of what it was. X squared plus 1 becomes negative x squared minus 1 when we add. And now the plus parentheses, and plus parentheses can just go away because plus parentheses don't really mean anything. And now we just say 2x squared plus 5x plus 6 minus 2x plus 3 minus x squared, squared minus 1 equals c. And now we've got c described by all these terms, which are just three polynomials now kind of written in terms of their terms, because we're not subtracting anymore, we're adding. Adding parentheses means adding parentheses goes away. Now we've got some terms that we just combine. We combine like terms. What are the like terms? Like terms have exactly the same variable to exactly the same power. So 2x squared minus x squared. Again, you can use the column method if you want, or you can just go through and use the linear method and say, all right, I'm going to combine all of my x squareds. Here's my x squared, here's an x squared. We'll combine it by saying 2 minus 1 gives me just 1 x squared or x squared. What about my x's? Let's combine all the x's and say, well, here's an x term, here's an x term, no more x terms. Plus 5x minus 2x gives me plus 3x. And now we're going to combine, we're going to combine the x to the 0 powers, or the constant terms. And we're going to say it's plus 6 minus 1 plus 6 minus 1 gives me plus 5. And there are no more, oops, sorry, I forgot that one too. Sorry, let's go back up here, erase, and say, now plus 6 plus 3 minus 1. 6 plus 3 is 9, minus 1 is plus 8, equals C. And there is our description of C in terms of all the x's, because what we wanted to do was find a polynomial that represents the length of the missing side, and the length of the missing side was C. C was equal to P minus A minus B, and we just filled in some terms, and we combined like terms down here after we changed the subtracting a polynomial to adding its opposite. Subtracting polynomial becomes adding its opposite, and we combine all the like terms after we throw away the plus parentheses, and we got to the answer of x squared plus 3x plus 8. All right, any questions? Bring them to class. We'll go through another example, I guess, in the homework.